every paper will have one problem from truss. In the past 10-15 years, I am observing every paper. Rarely there will be a paper without a problem from truss. So there are only exactly 16 problems, and this problem already answer known. For a statically determinate plane truss. Statically determinate plane truss. What's the relation between number of members and what's the joint? Number of members and number of joints. Directly it is m equal to 2j minus 3. Go for the next problem. Listen. A two-member truss ABC. So this question is very simple. Already you know I have solved it in the truss algebra. Okay, that's why I'm moving forward. A two-member truss ABC. Sir, for a truss, how many minimum members should be? 3 now. What is 2 member? A, B, C. 2 are there. The third is the wall. That is also a member. Even if they didn't mention, still when there are 2 supports, there is a ground and you can treat it as a member. There's an internal meaning. Are you okay? See, even though, this member is not there is a member because the wall is, whatever the support it is, whatever is there between them, there's a ground. That ground is acting as a member. Okay? So it's a 3 member, but okay, fine. 2 member truss ABC is shown in figure. This is the ground. So the 2 members are only there. But technically there are how many? 3 members. Force transmitted in the member. Which member he is asking? Force transmitted in the member. Force transmitted in the member. AB. Force transmitted in this member. AB. He is asking what's the force transmitted in this member? AB. Now, we have 2 methods to solve the problem. Listen to me carefully. I want you to digest the method properly because you can do the in exam within half minute, maximum 1 minute this problem. Listen carefully. What's that? They have 2 methods. Method of joint, method of sections. What's the rule in method of sections? Section or cut the truss in such a way that my member of interest is section. So AB is member of interest, I can section it. Next, or the next point. Take care that none of the joint is isolated. What's the meaning of none of the joint is isolated? That means on each side, at least there should be 2 joints. How many are there, sir? 3 are there. How many are there? 3 are there. If I keep 2 on one side, how many left out? Only 1. How can I get on both the sides 2? That means there should be minimum 4 joints if you want to go with method of joints. Whenever there is a 3 joint or 3 member truss, 3 joints or 3 member truss, only method of joints. There is no method of sections, because if you section 2 on one side, on the other side there is only 1. How can you solve it? Okay, so only do what? Go with method of joints. Whenever there is a 3 member truss, go with method of joints. Next. So now the method is finalized. I'm going with which method? Method of joints. I'm going with method of joints. Listen to me carefully. Next. Step 1. What is step 1? Tell me what's step 1? Find the support reactions. Find the support reactions. Find the support reactions. And what I suggest is never find them in the starting. Listen. Only if it is necessary, I will find the support reactions. How to know that? Listen. The method what I have given, I told already, it's a conventional method that will give us the idea of how to solve a truss. But how to do it, I will explain now. Listen. AB. What's that? How to go with which method? Method of joint. What's the second step? Draw the free body diagram of joint of interest. What's the second step? Draw the free body diagram of joint of interest such that the joint is attached to the member. So my member is AB. Which joint is attached to the either A or B? So draw the free body diagram of either A or B. If I draw the free body diagram of A, A is having a support, and I need to find support reactions. If I draw for B, there is no support, no need of support reactions. So, sir, for every problem it won't happen like that. For this problem, if I draw the free body diagram at B, no need of support reactions. So I'll skip the step of support reactions and I'll draw it B. See, joint of interest, your wish, but the only condition, it should be attached to the member. It is attached to the member. Now, next third step, what he told, take care that not more than 2 unknowns are created. Why? Because it's forming what? If you draw the free body diagram of B, it is a CCFS, coplanar concurrent force system. So if it is a coplanar concurrent force system, not more than 2 unknowns should be created. Not more than 2 unknowns should be created, because I cannot solve beyond that, because I have only 2 equations of equilibrium. So how many are there? See, this is the applied load. I know this. This is the applied load. I know this. See, this is the one member, this is the other member. So I will get two support reactions, 2 unknown forces. So yes, CCFS, 2 equilibrium equations, I can solve 2 unknowns. So what to do? First, draw the free body diagram of joint B. Free the body from everything and draw the sketch. Free the body from everything and draw the sketch. What's that I'm doing? Free body diagram of joint B. This all in the mind you should do in a second, sir. Draw the free body diagram of B. Free the body from everything and draw the sketch. Done. Next, actions. The only load acting on it is 10 kilonewtons vertically down. 10 kilonewtons vertically down. 10 kilonewtons vertically down. 10 kilonewtons vertically down. Okay. Next. There are 2 members attached. One is AB and there is BC. AB. So I told very clearly what's that? The members in the truss are having only axial loads. So that means the force is along the member. Either it will be under compression or tension, the force is along the member. But what I told, I don't know whether it's under compression or tension. I will take always the force towards the joint. If it comes positive, my assumption is correct and the member is under compression. If it comes negative, my assumption is wrong, it is under tension. Are you okay? Now FAB and one more is FBC. FAB and FBC. Let us say this angle is theta. This angle is theta. Okay. Now please all of you see here. Let's see. This is FAB. This is FAB. This is FAB and one more is there. This is FBC. Okay. FAB, FBC. This is FAB. This is FBC, and FBC is making an angle of theta with the horizontal. Sir, how many forces are there? 3 forces. And what is the system? Coplanar concurrent force system. Coplanar concurrent force system. And the joint is in which equilibrium? Static equilibrium. Can I apply Lami's theorem? Or not? Tell me, can I apply Lami's theorem or not? See, listen. This 10 kilonewtons down is given. No, I know pakka the direction. What about FBC? Who knows whether it is towards the joint or away from the joint? I don't know. So that means I don't know the angles. See, if it is like this, then it will have one angle. If it is like this, it will have one more angle. I don't know. The directions are assumed by me. I have taken towards the joint. So I cannot do that. Yes, sir, it's also 180. If I take in that, I don't know first of all the directions. Then there is no talking about it. I don't know the angles. So no, I cannot apply what? Lami's theorem. But don't ask me, sir, in the books they have applied Lami's theorem. What they are doing is, by experience, they know whether they are under compression or tension. They are taking that direction and they are doing it. But, sir, maybe I am experienced, I may know. But some problems I am also not experienced. I may also go wrong. And I don't want it. Okay? So I am not going to take any risk. Because there is -1/3. If you are writing an university exam, do that and come. At least if it goes wrong with the answer, that fellow will give some 5 or 6 marks out of the 10 or 7, whatever it is. But it is great where he will happily have a negative mark. He will be very happy. So for that reason, I am not going to take any risk. In my trusses and frames, when I am dealing with trusses and frames, as I am assuming the direction, never I will go with Lami's theorem. Then how to do it? We have static equilibrium equations. What is the static equilibrium equations? This is already in x direction, this is already in y direction. So resolve this. If I resolve, what is this going to be? FBC, cos theta, adjacent. This is opposite. So this is in like this. So it will be upwards. It will be, see, it's like this. I have assumed like that. So take it upwards. So FBC, sin theta. This is FBC cos theta. This is FBC sin theta. He is asking what? Find the load in the member. AB, right? AB, right? Now tell me, I have to get AB in this. So where I can get AB? See, if I write in x direction, I have AB in x direction. If I write in x direction, but I don't know FBC. First, I should find FBC. Then I have to go for that. Okay. So from here, I won't go simply blindly x, y, moment and all. Okay. So here I will follow the procedure. For first y direction. What is in y direction? It is in static equilibrium. So what I can write? Sigma Fy equal to 0. What are the forces? 10 kilonewton is acting down. So minus 10 plus FBC sin theta is equal to 0. So what is FBC? Minus 10 if it goes that side, plus 10 by sin theta. Into sin theta will become by sin theta. Keep it. Next, there's no moment, sir. It's a point. Only I have two equilibrium equations, y direction and x direction. So y I have already used x direction, static equilibrium. So sigma Fx equal to 0. What are the forces in x direction? FBC cos theta, FAB. Both are in positive direction. So what I can write? FAB plus FBC cos theta is equal to 0. Now I want FAB. What I want? FAB equal to minus FBC cos theta. What is FBC? Already I know. Minus 10 by sin theta into cos theta. If I get that cos down, sin theta by cos theta is tan theta. Minus 10 by tan theta. What is tan theta? What is tan theta? What is tan theta? This is theta. This is 0.5, this is 1. Tan theta is opposite side. What is opposite side? 0.5. By adjacent side, 1. So tan theta is 0.5. So it is minus 10 by 0.5. What will be minus 10 by 0.5? 0.5 in the sense 1 by 2. If it comes to the top, it will become, so as tan theta is 0.5. Tan theta is 0.5. From that I am directly writing what's that? Minus 20. What is this? Kilonewtons. Minus 20 kilonewtons. Listen. What I got? What is this? FAB. What I got? Minus. What's the meaning of minus? My assumed direction is wrong and it is in tension. Don't check what I have taken and all. Directly I'll say positive compression. Negative, my assumed direction is wrong and it is in compression. So what's the answer? The load transferred to FAB is 20 kilonewtons tension. 20 kilonewtons tension. So what's the answer here? He didn't ask the 20 kilonewtons. If he asks, we can say what is that? Tension. Are you okay? Now listen. For the truss shown in figure, the magnitude of the force in member PR. What's the member? PR. In this member he is asking. Okay. Force in a member PR. Okay. And the support reaction at R. He is also the support reaction at R. See, R is what support? R is what? Roller support. And he is asking the support reaction at this support. He is asking the support reaction at this support. 2 he is asking. What are those respectively? See, in the previous problem, he is not asking support reaction. So I said don't find support reactions. But now he is asking support reaction. So what to do? First find out support reactions. But he is not asking at Q. He is asking only at R. Keep that in mind. Only at R. Next. How many members are there? 3 members and 3 joints. As there are 3 joints, can I go with method of sections? If a section 2 on one side, other side only 1. So I can only go with method of joints. And he's asking the force in which member? PR. So that means I have to draw the free body diagram of either PR, R. So anything, PRR, no problem. Anyhow, I am finding the support reaction here. I will draw for P, R for R. That will not be having any trouble for me. So I will go with R because it's looking simpler. So I will go with R. Okay. So first find the support reaction at R, then draw the free body diagram of R. Okay. This is the plan. First find the support reaction of R, then free body diagram of R, and get the force in load PR. So first support reaction. Draw the free body diagram for the completers. How to get it? Consider the entire truss to be a single body and find out the support reactions. Consider the entire truss to be a single body and find out the support reactions. Listen all of you here. Consider the entire truss to be a single body and find out the support reactions. Consider the entire truss to be a single body and find out the support reactions. This is my PQR. PQR. Okay, okay. PQR. Good. Next, fill the body from everything and draw the sketch. Done. Next, actions. Sir, there's only one load, that is 100 kilonewtons, making an angle of 60 degrees with the horizontal. There's only one load, that is 100 kilonewtons, making an angle of 60 degrees with the horizontal. Making an angle of 60 degrees with the horizontal. See, this is 45, right? This is 45. So I have 60 degrees like this. Okay, okay. Okay, I have a load of 100 kilonewtons, making an angle of 60 degrees, making an angle of 60 degrees with the horizontal, 60 degrees with the horizontal. All of you are okay? Fill the body from everything and draw the sketch. Done. Actions done. Next, only one load, action done. Reactions. At Q, listen to me. At Q, what is the support? Hinge support. As it is hinge support. As it is hinge support. As it is hinge support. It will offer maximum 2 support reactions. It will offer maximum 2 support reactions. Okay, okay. And at R, I have a roller support. So it will offer only 1 support reaction. Only 1 support reaction. This is the one. Okay, okay. Listen here. RQX, RQY. This is R, RY. There is nothing in X, so it is complete R. Okay, okay. Now, what is the support reaction I have to get? Which one he is asking? He is not asking RQX and RQY. He is asking RRY. That is RR. The support reaction at. See, there is no X. So this is nothing but the total support reaction at R. So I want this RRY. How to get it? See, if I write the equation in X direction, I will get RQX. If I write the equation in Y direction, I will have these 2 terms. So I have to solve it. So for that, what we do? We will write the moment equation. Where to sit and write the moment equation? If I sit here, this will be eliminated and I will get these 2. Even this will go off because it's the same line of action. And I will find this. Then I have to substitute in Y. But what's the best way? What's the best way to get this directly? No need of X, no need of Y. Just go and sit here. Now don't write in X and Y. See, now I am not going to follow the method X, Y and all. Whatever I want, precisely I will go for it. Are you okay? See, in the exam, don't draw even free body diagram. You go sit and get it. But now practice. Now first practice. Okay. See, I am going and sitting here. Now first directly I will take what? Moment. I will directly take what? Moment. So it's in which equilibrium? Static equilibrium. So sigma m should be equal to 0. With respect to which point? Q. I am sitting at Q. See, moment due to RQX 0. Moment due to RQY 0. See, this 100 kilonewton is at some angle. First what to do? Resolve it. If I resolve, this is how much? 100 cos 60. This is 100 sin 60. So what will the moment because of 100 sin 60? See, the line of action is passing to this. So moment due to that is also 0. We have 100 cos 60 R. Now. What is this like? What is this thing? 4 meters. This is 45. What will be this? Same 4 meters. Array sum of 45 degrees equal intercept angle. 4 meters. Same 4 meters. Because 45 degrees angle. Sine, you take tan 45. 1. Opposite side by adjacent side. So 4 meters. Okay? Okay? Now please all of you see here. See here. See how this? This is 4 meters. This is also 4 meters. I got the lengths. Now please see. First let us see. 1, 2, 3 all gone. I have only these 2 forces. 100 cos 60. Clockwise or anti-clockwise? From here. Clockwise or anti-clockwise? Clockwise. So minus 4 into 100 cos 60. Plus. So I don't know. Right? See this anti-clockwise. So plus 4 into RRY. So 4 is common, remove that. RRY is equal to, send it this side, 100 cos 60. Cos 60 is 1 by 2. So it will become how much? RRY, this is nothing but the total support reaction. How much is that? 50 kilonewtons. I got the first one. Whatever he is asking, the first one, support reaction at R, I got it. RR, I got it. Okay. Next, I want the load in the member PR. See, you can sit here, resolve this. From here itself, these 2 will become 0. This is passing through this 0. This component is equal to this component. Both are 4 and 4. Remove that. This will be equal to this. You should get like that in the exam. Okay. But now they are kids, we'll follow the method. Okay, I have skipped already 2 steps, so we'll follow slowly we'll skip them. Okay. But if you do it in the starting itself, there is a chance of committing more mistakes. So first do properly in the conventional method. As you practice more and more, you will get habituated, and then you can automatically do it. Okay. Now, either I can draw the free body diagram at P, R at R. So what we thought, we have to draw it R. Okay. So what's that? Free the body from all the constraints and draw the sketch. Now draw the sketch for R. Draw the sketch for R. It's nothing but a joint. So this is the joint. Free body diagram of R. Free body diagram for R. Next. Any actions? Any actions? There is no actions, but I have a known reaction. I have a known reaction. RRY is how much upwards, acting upwards. How much? I got positive. That means my assumed direction is correct. So how much is that? 50 kilonewtons. I have a known reaction. I have a known reaction. How much is that known reaction? I have a known reaction. What is that known reaction? RR, that is equal to 50 kilonewtons vertically upwards. 50 kilonewtons vertically upwards. Next. What are the members attached to this R? What are the members attached to this R? PR and QR. How they should be taken? Towards the joint along the member. QR is horizontal. PR is making an angle of 45 degrees with the horizontal. So what are the reactions going to be? One like this, QR. And this is what I have to find out. That is my PR. Okay. This is what is FQR. This is my FPR. This is making an angle of how much? 45 degrees. First, what to do? First to resolve, sir. First to resolve. Whatever is given in the problem, first to resolve. FPR. If I resolve. This is how much? FPR. Sine 45. This is how much? Yeah, sorry. This is adjacent side. But we have one provision here. If it is 45, no problem, sine or cos. Both will give me the same. But follow. This is the cos component because adjacent side is cos component. Okay, don't do that. FPR sine 45. Now, what is that I want? FPR. It's there in both an x direction and y direction, but I don't know FQR. If I know FQR, I can write in x direction, but I know RR. So, write in the y direction. Don't sit and write x direction, then say, I will go for y direction, then I will solve. No need. Directly write in y direction. Static or dynamic? Static. So, sigma Fy is equal to 0. RRY, whatever it is, it's acting upwards, so positive. FPR sine 45, that is acting downwards, so it is negative. FPR sine 45 is equal to 0. RR is 50 minus FPR into sine 45, 1 by root 2 is equal to 0. Minus, see, this you send that side, so into root 2. FPR is equal to 50 root 2 kilonewtons. What is 50 root 2? 70.71. Is it coming positive or negative? Sorry, is it coming positive or negative? Positive. So what's the meaning of that positive? It is under. The member is under compression. I got it compression and I got the value already. Okay. Is the options given? Yes, sir. 70.71. He is asking first PR and then R. So 70.71 and 50, which is having that only one option, that is C. Only one option, that is C. Okay. See here. The force in AB of the truss with load P equal to, how much is P? 500 newtons. It is given 500 newtons. Okay. And support system as shown in figure will be. So he's asking the force in AB of the truss. Where is AB? This is AB. He's asking the force in this member AB when P is equal to 500 newtons. See, now if you draw for A or B, draw for anything A or B, what's the problem happening? Both are having supports. See, in the first problem, I have an option, so I didn't find the support reactions. In the second problem, he is asking. So, okay, fine, I have found it. Now he's not asking, but both ends of my member are attached to the supports. So hence, no way I have to find the support reactions. Here, how many are there? 2 are there. Here, how many are there? Only 1. So, which one is better to find? At B. If I want to find at B, where should I go and sit? I should sit at A and write the moment equation. Okay. But now, I'll draw the free body diagram. I'll do it because slowly we'll go. Okay. For the time being, I will do it. But the best way is what? Sit here, take the moment with respect to A, and get the support reaction at B. Okay. Okay. We'll do the same thing, but a bit slower, sir. I am a kid, sir. I am only a kid. Huh? You people are experts. You people are experts. 3, 3, 4. So 6, 4. Okay, very good. Very good. Very good. 6, 4. Yes, it appears like that. Yeah. Now free the body from everything and draw the sketch. Done. Next, actions. Only one load is there. That is 500 newtons. Listen. With vertical. It's not with horizontal. With vertical is making an angle of 30 degrees. With vertical is making an angle of 30 degrees. Be cautious. Every problem, they kept something so that they will commit mistake. Huh? Just for reference, I'm drawing, sir. Just for reference, I'm keeping. Okay. Okay. How much? 500 newtons at an angle 30 degrees with the vertical. At an angle 30 degrees with the vertical. Okay. How much is the force? P equal to 500 newtons at an angle 30 degrees with the vertical. Are you okay? I'll write here 30 degrees. Okay. Now free the body from everything and draw the sketch. Done. Actions, only one action P. Done. See, beams are massless, so I'm not having anything, only the load. Okay. Next, reactions. At A I have a hinge support, at B I have a roller support. So hinge support will offer maximum 2 support reactions, roller support will offer 1 support reaction. Okay. So at A, I have hinge support, so it will be offering 2 support reactions. At B, I have a yes. How much is this? RAX, RAY. This is RBY, RB, because only 1. Okay. So this is what we have. Fill the body from everything and draw the sketch. Then actions done. Okay. Now what to do? Find the moment. So just before going to that, resolve this. If I resolve this. If I resolve this, it is 500 Newton down. So this is what? Adjacent side now. It is with the vertical. This is the adjacent side. So it is 500 cos 30. 500 cos 30. And this is opposite side. So this is 500 sin 30. I want what? RBY. So no need of writing in X direction. If I write in Y direction, I have one more. It is already Y. So X is not useful. In Y, I have one more unknown. So that is also not useful. What's the best thing? We already find out. What's that? Go and sit at A. Happily sit at A. Now, with respect to this point A, write down what? Moment. Static or dynamic? Static. So moment, static equilibrium, sigma m with respect to A is equal to 0. Tell me moment due to RAX, 0. Moment due to RAY, 0. 500 cos 30. Clockwise or anti-clockwise? 500 cos 30. Clockwise. Clockwise according to us is minus, what's the distance? See, this is 3 meters. 3, vertical is 4. Yes or no? It's given. 3 meters, 4 meters. So this is how much? 3 meters. So 3 into 500 cos 30. 500 sin 30. How is 500 sin 30? Like this. So that is anti-clockwise. Anti-clockwise in the sense plus. See, for this, listen, it's at the same point, but this is the line of action. So the distance is 3. Same point, but this is the line of action. So what's the distance? 4 meters. So plus 4 into 500 sin 30. 500 sin 30. RBY. It's at a distance of 6. Clockwise or anti-clockwise? Anti-clockwise. So again, plus 6 into RBY is equal to 0. So I have to find RBY. So 6 RBY is equal to, send it this side, 3 into 500 cos 30, minus will become plus, minus 4 into 500 sin 30. Now please get this. 300 cos 30. $49.83. Hope I'm correct. 49.83 newtons, because he has given in newtons. Okay. Next, I got RB. I got C. I want to find the load number AB. I got RBY. Now draw the free body diagram of joint. B. So it's nothing but the joint. So I'll have only a point. Free the body from everything and draw the sketch. Done. Actions. There are no actions at B, sir. But I know a support reaction. Already I have a known support reaction. What is a known support reaction? RBY. Oh, gee. RBY, how much is that? 49.83. 49.83 RBY, let us say it's RB. Okay. Known support reaction. Okay. RB, how much is that? 49.83 newtons. So there's no X component, so I'm directly taking RB. Okay. Next. It's having two members in contact. What are the two members? AB, BC. Okay. So towards the joint, along the member. Two support reactions. Towards the joint, along the member. See, this is FAB. This is what I have to find. Second one is like this. I don't know the angle, sir. Let me say some theta. Let it be some theta with the horizontal. Okay. So this angle is theta. This angle is theta. This is FAB. This is FAB. This is FBC. Okay. I want what? AB. How to get AB? See, previously I have the option. What is that option? So first resolve. Previously, what's the option I have? I want the components. I want FPR, I think, right? That's the one. So I have taken this component and equated it. But now AB. So what to do? First resolve this. If I resolve. This is FBC sin theta. And this is I think this is not that visible. FBC sin theta. This is FBC cos theta. See, I want in the previous problem FBC, so directly I have equated these two, but now I want FAB. In X direction I have FBC and FAB. So if I know FBC, then I can find FAB. So first write in Y direction and get FBC, then get the FAB, right? So Y direction, static or dynamic equilibrium? Static equilibrium. So I can write sigma Fy is equal to 0. So RB acting up or down? Upward. So plus, FBC is acting down. So minus FBC sin theta is equal to how much? 0. So what is FBC? What is FBC going to be? See, send FBC sin theta this side, RB will be there. So let's say RB. So sin theta down. So RB by sin theta, that is 49.83 by sin theta. 49.83 by sin theta. FBC is equal to 49.83 by sin theta. Are you okay? Next. In X direction, is it in static or dynamic equilibrium? Static. So what I can write? Sigma Fx is equal to 0. Now what are the forces in X direction? FBC cos theta. I'm sorry, is in positive direction or negative direction? Positive. So plus FBC cos theta. Next, FAB, that is also in the positive direction. So plus FAB is equal to 0. From this, what I can write? FAB is equal to minus FBC cos theta. FBC is what? I have already found out. Minus 49 point, sorry, minus. FBC is 49.83 by sine theta into cos theta. So if I get cos theta down, sine theta by cos theta is how much? Tan theta. So minus 49.83 by tan theta. What is tan theta? What is tan theta? Opposite side is 4, adjacent side is 3. 4, 3. So it is, tan theta is how much? Tan theta is how much? Tan theta is how much? Opposite side 4 by adjacent side 3. 4 by 3. So if I substitute that, what will I get? What will I will get? Minus 49.83 by 4 by 3. So how much I will get? Into 3 divided by 4. So 37.37. 37.37. Kilonewtons are newtons. He has given in newtons. Yes or no? Let me check. The load is in newtons. So it will be in newtons. So how much is that? How much is that? Finally, what is my answer? What is my answer? FBC. Sorry, FAB is equal to minus 37.37 newtons. Okay, so fine. So minus indicates what? Minus indicates what? The member is under tension. My assumed direction is wrong. It is under tension. Are you okay? So one more problem. One more on same. See, here also I cannot go with method of sections. That's why I went with method of joints. See, how many are there? Only 3. So I went with method of joints. Now one more problem. Now see. Find in the loading and support system shown, the member AB of the truss is subjected to 1000 newtons tension. Listen. Hurry. See, he has given 1000 Newton tension. What's the meaning of this? What's the meaning of this? Now he is not giving the load applied on it. He has already told that this member AB is having 1000 newtons tension. That means towards the joint compression, away from the joint is tension. The load is tension 1000 newtons. What will be the weight W? That means instead of giving the weight and asking the load in the member, he gave the load in the member and he is asking what's the weight. It's fine, we'll find it out. Okay. Now how many joints are there? 1, 2, 3 joints. 3 joints. Can I go with method of sections? No way. Why? Because if you cut 2 on one side, 1 will be on the other side. 1 means that is again method of joints. Okay. So I have to go with method of joints. Now I know the load in this member. And I want to find this W. Now, both are connected at A. Now, is there any requirement to find the support reactions? See, 1, 2, 3. In them, I know already this one. So I have to find these. I can find these 2 are unknowns. What is that? AC and W are unknowns. I will find W. 2 unknowns. CCFS. Can I solve or not? Yes or no? So, no need of finding support reactions. So, directly go for what? Free body diagram of joint A. Directly go for what? Free body diagram of joint A. Fill the body from everything and draw the sketch. Done. Next, actions. Whether you know or not, what's the action? I have applied a load W. See, where you have seen such a structure? Such a structure? Cranes. See, the cranes, they have hoists. They use this. Okay. So, it's carrying a load W. Okay. So, this is the action. So, it's pulling the joint A with a vertical force W. Directly I will take it, sir. Okay. So what are the actions? At A, I have a load. How much? W acting vertically down. Next. And at A there are 2 members. What are the 2 members? AB, AC. Okay. Just before going to that, let me do one more thing. That is, let me select the angles. So what are the angles? See. This is how much? 150. What's the height? 150. See, if this is 150, this is 150. Both are same. What will be this angle? 45 degrees. Already I know this. So this means it is making an angle of 45 degrees with the vertical. If this is 45, even horizontal also 45. Even this is also 45. No problem. Now, what about this? So with horizontal also it's making 45. This angle I don't know. That I am saying theta. Later if I require I will find. Otherwise leave. I am saying for the time being theta. Okay. Now please all of you see. 2. I have 2. Okay. What are those 2? How I have to take? towards the joint, actually towards the joint, but already given in the problem was that 1000 Newton tension. 1000 Newton tension. What is the meaning of that? What's the meaning of the 1000 Newton tension? What's the meaning of the 1000 Newton tension? That means if it is towards the joint, that means it is under compression. That means this force AB is already known. It is away from the joint. How much? 1000 newtons. Now, why again? What's that? I have to take towards the joint and write minus. Okay. So already given tension. So not towards the joint, away from the joint, 1000 newtons. What is AB? 1000 newtons. Already I know. So I'll directly take it. What's that? It's making an angle. Theta with the horizontal. How much is that? FAB, as it is given tension away from the joint, how much? 1000 newtons. One more I have. What is that? FBC, right? Sorry, FAC. And this is FAC. It's making an angle of how much? 45 degrees. This is 45 degrees. This is theta. This is 45 degrees. What is this? FAC. 45 degrees. Okay. Now I have to get this W. So before going to that, how to solve it? Before going to do that, first to do what? Resolve them. First I will resolve this. If I resolve this, I'll get one component like this. What is this component? FAB, that is 1000 adjacent side. So cos theta. 1000 cos theta. One more. See, like this. So downwards. Sorry, I did a mistake. What's the mistake? I know FAB, so I have taken towards the joint. Sorry, away from the joint. But FBC, always I will take it. Towards the joint. No change. This is FAC. Making an angle of how much? 45 degrees. This angle is theta. Okay. Now, please all of you see here. Resolve them. First resolve them. If I resolve, this is how much? Adjacent side. So 1000 cos theta. This angle is theta. And this is going to be, see, one more component. See, like this. So one more component. How much is that? 1000 sin theta. There is one more force. What's that? One more force. I will go with this three. Okay. FAC. So I'll get, see, it is like this. So opposite direction. Angle 45. So FAC adjacent side. So cos 45. It's like this. So like this. How much is this? FAC sin 45. Okay, so I have resolved them. Now these two are not there. All are in X and Y direction. Now I want W. I know 1000 sin theta, but I don't know FAC. So first to solve X direction and get FAC. Now we can get W. Okay. Sigma Fx is equal to 0. Sigma X direction. What's that? It is in static equilibrium. So sigma Fx is equal to 0. FAC cos 45. Positive direction or negative direction? Positive direction. So FAC cos 45. This is in negative direction. So minus 1000 cos theta is equal to 0. So I won't solve. I'll just find out what is FAC. What is that? 1000 cos theta by cos 45. Because let me check what is the requirements. Okay. Next. Y direction. What's happening in Y direction? Static or dynamic equilibrium? Static. So sigma Fy is equal to 0. What are the forces? W down. So minus W. 1000 sin theta minus 1000 sin theta. FAC sin 45 plus FAC sin 45. What is it? Is equal to 0. So what is W, sir? What is W? Take it this side. So what I'm left with? FAC sin 45. I'm just writing sin 45 minus 1000 sin theta. W minus W I have taken this side. This is positive, this is negative. So positive minus negative. Okay. What is FAC? Already we know. FAC 1000 cos theta by cos 45 into into sine 45 minus 1000 sin theta, minus 1000 sin theta. Listen. Sine 45 cos 45, 1 by root 2, 1 by root 2, gone. What I'm left with? I'm writing here. 1000, 1000 cos theta minus 1000 sin theta. So 1000 into cos theta minus sin theta. Now get this cos theta minus sin theta. See, this is theta, right? This is theta. Listen. This is 150, this is 150, right? See, that means if I drop here, this is the triangle. 150 plus 150, 300. This is 150. So what will be this one? Under root of 300, the hypotenuse now, 300 square plus 150 square. See, 150 into 2, 150 into 2. So 150 if I take common out, what I will get? 150, if I take out, what I'll get? 150 under, 150 into under root of, see, 150 taken 2 square will become 4 plus 1, that is 5. Okay, 150 take it out, what is left out? See, 150 square gone, 2 square, that is 4 plus 1, 5. Okay, 150 root 5. Now, what I want, cos theta minus sin theta, right? Cos theta minus sin theta. What is cos theta? Adjacent side. What is adjacent side? 300 by 150 root 5. Opposite side, that is sin theta, that is 150 by 150 by root 5. So if I take cos theta minus sin theta, 300, see, 150 root 5, 150 root 5, that is common. 150 root 5 is common. So, what's there in the numerator? 300 minus 150, that is 150 by 150 root 5. 150 gone. So cos theta minus sin theta is 1 by root 5. So substitute here. What is that I'm going to get? 1000 cos theta by sin theta, how much I got? 1 by root 5. So root 5. How much is that? 1000 by root 5. $447.21 newtons. See, why I'm getting positive, never it will come negative. If it comes negative, load is acting. W is load downwards. If it comes negative means, pakka you have done wrong. Go and check it. Don't say, sir, load is acting upwards, so it is pushing it. Check it up. Never will give a problem where load is pushing up. Maybe there may be given to confuse you, but 99% he will not give. Okay? So be cautious with it. Check twice. If still it is coming minus, then only take it. But definitely it has to come positive. Okay. Hope you have gained some knowledge from my lecture. If you feel so, please subscribe to the channel. Please leave your valuable feedback and doubts in the comment section. For my complete video lecture series, enroll in OCTEMY. Thank you. Let's catch you soon in OCTEMY. Have a good day.